Hey everybody, this is Brad Dyke reaching out to you to say hi, and wanted to talk now about storage protocol platforms. That's important because that is changing in the industry, and one of the key details relates to something very much like this Dell series NVMe support logic RAID controller. Now NVMe is one step beyond SSD because, matter of fact, I'll show you what it looks like. So basically, we have different types of NVMe environments. This is an NVMe stick right here, and this is a PCIe class NVMe as well. And of course, we have also more complex cards that which don't truly, how would you say, show the truth of the matter. This is not what you think it is. It is not a quad NVMe card. It is a divider NVMe card, which means you lose four, basically you only get 1/4 of the speed when you have all four of these things populated, which is terrible. Might as well keep the spinning disks. But the point is, then you can introduce what we call the controller, and the controller can come in and it can be able to do some really impressive things, because this guy does have an NVMe built into it too, and it's directly related and only the only NVMe involved with that PCIe bus. Now the value between that and the fact that when you have what we call an HBA style interface, may it be IP or may it be a protocol or may it be fiber channel, and what that means, it can be TCP IP, it can be fiber channel, it can be internal channeling for like SAS and so on. But here you have these block chips here which represent your bandwidth capacity. This is a 10 gig card, and that guy working with a burst NVMe service, which is important because it's not that large, but it's extraordinarily fast, and it has the ability of really being able to handle a lot of processes like the NVMe. Because if you know anything about NVMe, you can't give it anything like cache. Don't waste the money on caching when you have NVMe on board and you've got, like, let's say 4 of these sitting inside your PCI bus, for your PCIe bus, I should say, and you're like, why isn't it not doing what I want it to do? And the answer is pretty simple, because the pipe for a single NVMe can take up all the bandwidth that this port slot can use. And when you have to add more NVMe's, you have a divider factor in half, and in this case, quad. So to have cards like this are really nice, but you totally lose the value of NVMe unless something can help them buffer a little bit more. And unfortunately, it's not that great of a benefit. It's nice because I think we're finally figuring out what it means to open bandwidth NVMe capacity. When that truly takes effect, IOPS won't even matter. It will be just true IO bandwidth. That would be the correct terminology to use once that's been figured out correctly, and still work with the smart protocols and NCTAC protocols and DMS and so on that are required when it comes to managing volumes. That might even result in changing the nature of DMS and saying we're not going to treat these as drives anymore. We're going to treat them as something else. And it could relegate to being a pool, truly be a pool, which we don't quite do. We do that more on the hardware side. We take disks and pull them into a pool. We call that pool 1. In this case, if the DMS protocols, that's disk management services protocol, which do things like root access and so on, can do the same thing with a pool, then your pool could represent a petaflop. It wouldn't matter what it is. It could be technically infinity, which was a particular protocol we did have for a while, known as an infinity volume. And that kind of went to the wayside because of the complexity. But it never did reach its limit, as far as I knew of, not at least on the NetApp side. Let me set these aside real quick. Hang on a second. So with that being said, the nature of running right on the edge of PCIe at the best bandwidth it can possibly offer is based on how well you use this pathway versus how well you use the software and the controller. It goes back to the discussion. is your software tweaked out and optimized effectively to use your hardware the way it can potentially be? Now, even with that being said, the nature of NVMe is so fast, unlike SSD and everything else below that, SATA and SAS and so on, that it outperforms what you've got. There's nothing you can do about that. It's just what it does. So the best answer in the world is take two 14 terabyte NVMe cards, put them side by side, split your bandwidth in half, and you got a pretty doggone kick butt environment. Don't go out there and buy 4 of them and put them in a RAID 5 or a redundant RAID 10 / RAID 1+0 model and expect to get the same performance. You're not at all. The best you can do at best is the maximum size NVMe disk that's available on that little card times 2. And then you RAID 1 it and be done with it, because that's the most efficient way to use NVMe going forward for now. That's not cheap, but when you look at the overall, yeah, it can save you some money, especially on cost, because 2 very large NVMEs versus 25 of these saves you power. You just don't need them. And power consumption ratio is not so bad. Now remember, SSDs and equivalencies beyond do template basically not handle the power processes as well as a smart driven / spinning hard disk, because we have more experience with spinning hard disks and the code is written more efficiently for those environments. And we just haven't gotten SSD and NVMe up to the best parable models for what they are. That's coming. I've been waiting for a couple of years now for that, but eventually the new standards for smart will come out and it will do all versions of disk drives, and that would even include, believe it or not, USB sticks. Terrible, isn't it? But if you don't mind not having the performance, an NVMe card is really great for very tiny, high capacity USB sticks. They're really great. I have one here myself and I really enjoy it. Let me grab it. Oh, I guess I don't have it. All right. Well, anyways, yeah, it's a small rectangular style. That's it. Very small, very thin, easy to work with. Take it anywhere I want. Backs up everything I want. It's just I have to go at the speed of USB 3.1 speeds, or 3 point, or 2 point, or depending on what I connect it to. Please note that not all NVMe cards will work effectively USB-wise with ports such as 1.0. Might as well say that disclaimer now. So with that being said, this was just to talk about the nature of how there's some really good positive stuff coming up in the PCIe bus environment for NVMe. And there are new standards out there as well, as I understand, that are breaking that barrier, getting into what's called Infinity I/O. And Infinity I/O basically speaks to the nature of native buses designed for NVMe. And that's all it is. It's just better design, more pipes, and can they interact independently? That's an important detail for this to be successful. If it can interact independently of its environment, then it is going to be very successful in a nutshell. But if it can't, then it won't be able to truly do what we need it to do, and that is to maximize the I/O bandwidth across an open bus, which is far greater, far larger than the individual NVMe cards. So what I mean by that is, okay, if you look at a fiber channel switch, the reason why fiber channel switch was such a popular solution for storage is because they really did blow network bandwidth out of the water. TCP UDP versus fiber channel. The only reason why is because they did it right. They took every single port that was on the switch, as you can see, like the one behind me here. They took every one of those ports and then doubled it to the standing of the back end. That's called a redundant bus. So let's say we've got 10 gig pipes, right? Well, that's 100 gigs. So on the back end pipe, there's a 200 gigabit bus, or in this case, if it was fiber channel, there would be 10 8 gigabit connections, and there would be the equivalency of 2 80 gigabyte pipes designed for redundancy, of course, that are sitting there, and there's more bandwidth on top of that to handle the back-end traffic, the controller traffic, and the overhead traffic. And in such a way, it would give you the ability to have way more bandwidth as a whole in your switch assembly than the individual component of the fiber channel connection that you're making. So you'd have two connections like this guy going into two separate ports on your switch. They have 16 gig bandwidth capacity on each port. That's 32 gigs just for one server, right? Blisteringly fast disk storage capacity for fiber channel. But I need, let's say 120 of them. So that's 240 ports on a big switch box. That's going to be much bigger pipe to handle that traffic than ever would we see in the world of storage controllers for hard drives. So that's the Achilles heel in the storage industry today, is that we haven't figured out how to do infinity bandwidth for NVMe equivalencies. And it has to be huge. So if you've got 125,000 IOP on a single NVMe, then you need probably something in the billion range IOP open infinity bus. In other words, something can handle a heck of a lot more than that traffic. So let's say, because NVMe is small, by the way, you could have 500 of these in one disk environment, right? You'd have up here 250, and a boot drive, all fitting in 2Us, by the way. 250 NVMe devices. That's petabyte right there. What we're talking about. So with that, you need to make sure that those back-end buses can absorb all of that traffic per individual unit on a grand scale as a whole. That gives you the ability of being able to do what they successfully did with fiber channel in the past. Use that history to help us make us smarter in the future. Well, this is Brad Dyke saying goodbye. Unfortunately, I did another concept video. I apologize for that, but getting a lot of really great questions about NVMe, a little bit of frustration. I get it. When we're trying to take old gear off the shelves and repurpose it, that's part of the challenge, guys. We have to have a little bit of fun, figure out how can we break this? How do we make this smarter? How do we do this better? Well, I'm going to sign off here. God bless and have a great week. Bye-bye.